So one of the ideas behind this developer days was also to make it a kind of forum for presenting the technologies that we are not using currently in our work, but we somehow know about them, or we are interested about them and want to share this this excitement, technological excitement with colleagues. So to make it a start, I will tell you today about the technology. I took a little bit deeper dive recently in my well, evening and weekends. This will be the blockchain and cryptocurrencies, which is recently a very hot topic. And I would like to tell you today about this, but not from the perspective of financial dealing or trading the money. I would like to tell you about what technology stands behind all this hype about cryptocurrencies and blockchain. So usually when anybody starts to talk about blockchain and cryptocurrencies, it's mandatory to make a disclaimer that I am not financial expert. I'm anything I will tell today should not be treated as any kind of financial advice. And generally, the trading in cryptocurrencies is a very risky business. So do it on your own responsibility. Okay, let's after this mandatory disclaimer, let's start with it. The blockchain technology called blockchain was built on generally three principles. So first of all, the blockchain should be decentralized. That means that there is no third party in what we will be doing in blockchain. There's no central point, no authority over it. It just runs by itself and guarantees that nobody will mistreat this. So we are not trusting anybody, not like in the real life when we are trusting the bank, when we are trusting the insurance agency, or we are trusting the government. Ha ha ha. This is meant to be run independently, and it should be as difficult to kill as it is possible. Because basically blockchain runs on the principle which is known from the networks like BitTorrent or other peer-to-peer technologies. It runs somewhere, everywhere. The second principle is to provide the platform that on which the information once put into the platform will be immutable. So there will be no way to change this information. Everything that is written into blockchain stays written into blockchain. And the third one is how to achieve this. Everything is based not on trust, not on the people or institutions or other authorities. It is all based on cryptography algorithm and software. So it's a kind of world for us as software developers, because well, everything depends on software and it is self-governing in a way. So what is this blockchain? The blockchain, the anatomy of the blockchain looks like on this picture. So blockchain, like the name says, consists of blocks. The block is of arbitrary size, and the content of the block is just the list of transactions. So A pays B 200, B pays C 100, and so on, so on. This is the list of transactions. Once the list of transaction is big enough to create the block, so it filled the block. The block has to be added to this chain, and this chaining is a crucial for this blockchain to work, because once block is filled, somebody has to mine. I will tell you about it later. Somebody has to mine the ID of the block, and the ID of the block is basically the SHA 256 checksum. This checksum of the whole block. And the block is attached to the previous block by containing also the ID of the previous block, and this hash of the new block will also contain, of course, the hash of the previous block. So nobody is able to change anything in this chain without breaking it, because changing anything here will break this connection. There's no such thing as a current state of the blockchain. To calculate what is the state of your account, for example, in a blockchain platform, one has to go from the beginning of the block and calculate all the transactions that was made on your address to find out what is the current state. So it only contains, each block only contains the definition of transaction. There's no definition of, well, current state. Okay, so where is this block living? Where is this blockchain living? Because, as I mentioned previously, this is the peer-to-peer technology. This blockchain has to be distributed among the huge number of computers throughout the world. Yeah, so this is like torrent, where while you are taking part in a torrent network, your computer becomes the node in this network, and this node is peer-to-peer, and the algorithm, in the case of network, sends the files between you. In the case of blockchain, your node, because this is called node in this terminology, has to copy the whole history of transaction of the whole blockchain on your computer, and this in your computer will start to be a kind of a validator for the other transactions to occur. So if any transaction has to occur in the blockchain network, more than half of the computers taking part in this network has to validate this transaction. So has to say, okay, this transaction is okay. It agrees with the state of the chain as it is on my local disk. Which, of course, I can see your surprise, because this is, of course, the bottleneck as far as the development of the blockchain technology is concerned. Because, well, in a case of millions and millions transactions per second, this hard disk will be filled up very, very fast, and of course networks will be clogged. That's why this is one of the factors that is currently limiting the growth of the blockchain technologies, because the number of transactions per second is limited due to this problem and due to problem connected with the consensus algorithm and mining. I mentioned before on this slide that here are the account A which pays B the money and so on. So how do you create account? What governs the accounts? How do you go to blockchain and make your own account? Because this is decentralized, well, you do not have to go to the bank and show your ID and have the account established. All you have to do is to generate the pair of cryptographic keys, your public and private keys, and the hashed version of your public key becomes your address. And you are, of course, supposed to store somewhere secure in a secure place your private part, because this private part is something that you will be using to sign the transaction on the blockchain. It is also worth mentioning that once you lose the private key, there's no need to recover it. There's no procedure like in a normal bank to recover your account or to get the access to the money. This is forbidden by the very nature of the blockchain. Sorry, no way. As a fun fact, a lot of bitcoins currently present on the Bitcoin blockchain is lost because their clueless owners just lost the private key, and there's no way to recover them. So there's a lot of money somewhere there lying without owners. Okay, I mentioned that more than half of the network has to agree about the state of the chain and before the transaction is validated and added to the chain. So how does it work in practice? There is something very important called consensus protocol in blockchain networks. There's also one thing I should mention here. There's more than one blockchain. This is not only Bitcoin. Right now, there is over 1,600 cryptocurrencies and blockchain platforms in the world. Everybody wants to have the piece of this cake for him. There are different consensus protocol and different ways to resolve things that are becoming the problem on these platforms. So the consensus protocol generally is a protocol that elects the one of the computer in the network to be able to initiate creation of the block. So this one of the computer gets elected, and one of the computer is then responsible for calculating all these hashes and adding this to the blockchain, and then half of the network has to confirm it to be valid. But of course, the network is decentralized. So how do we pick which one is now in the current state, which one is supposed to create this block? This is why the consensus protocol was invented. Consensus protocol selects the computer which creates a new block. There is a number of types of this protocols. The most popular are proof of work protocol, which is used in Bitcoin and currently still in Ethereum. And there is something called proof of stake, which works on a different principles, and it is used in a third generation cryptocurrencies like, for example, Cardano. What is also very important to say here that the owner of the computer who becomes elected for creating new block is also paid for doing this. So this is the reward you are getting if your computer is connected to the network of the blockchain. And this is where we go to the mining term, because well, everybody is talking about the mining, about the environmental impact of the mining on our planet and so on. So what is this mining? What do the people mine? The mining is really execution of this proof of work algorithm. So these millions and millions of the GPU cards that you are not able to buy currently are now doing the mining of this, are calculating something to be elected as a next computer to add something to the Bitcoin blockchain and be rewarded. I suppose the current reward is 12 Bitcoins for this operation. So taking the price of the Bitcoin into consideration, it's quite a lot of money. You will get 12 Bitcoins for this. Okay, so this proof of work protocol we are talking about, this is the earliest protocol in this blockchain family. It is right now used with a success in the biggest cryptocurrencies like Bitcoin and Ethereum. The downside is that it demands a lot of processing power to run those GPUs and ASICs machines to generate the blocks, and also uses, of course, a lot of electric energy. In fact, this was kind of designed to drive the power rates for this network to become more and more powerful powerful. In design of this protocol, there is also the rule that will shrink the number of bitcoins every, I suppose, 2 years that you will get for mining the block. Of course, the short side effect is the shortage on the GPU market. So what is this? What does those millions of GPUs do? They are basically calculating SHA-256. They do nothing more. They are calculate this hash blindly. And how does it work? So once the block is supposed to be added, everybody in the network tries to find out the solution to the following problem. For the block to be complete, you are calculating SHA-256 from the list of transactions, from the hash of the previous block in the blockchain, and from the value which is called nonce. Nonce, it's like a number used once. And this nonce has to be found because the solution of this riddle is to generate the SHA hash, which will have the first n bits equal to 0. So they are just incrementing this nonce or generating random nonces to find the value of the nonce for which the SHA of this block will have the n bits equal 0. So it's just because the SHA-256 is a cryptographic hash, there's no way to make a reverse calculation. So the only way is to just blindly and randomly generate this nonces and check if the first n bits are 0. So this is what all this electricity is used for and what all these GPUs are doing right now. Once it happens, first machine that does it becomes the provider of the new block and is able to add this block to this blockchain and gets rewarded with the bitcoins. This has obvious downsides, as I mentioned before. Despite this high energy usage and this race of power, it also creates the situation where the number of transactions which you are able to perform in a Bitcoin network tends to be very low, because the whole blockchain can make only the number of transactions that will fit into one block, and then somebody has to find this nonce, somebody has to mine it. So this speed of the blockchain transactions per second is limited. There's just a handful of them per minute right now. So of course there's no way to for Bitcoin to become a global currency right now, because globally, well, the globe generates millions of transactions per second. This is what blockchain cannot do right now. In the Bitcoin version, of course. So the next generation platforms invented different consensus algorithms, and one of them, which is kind of second popular, is algorithm called proof of stake. It is currently used by the third generation like Cardano, and Ethereum is supposed to switch to the proof of stake protocol. It was supposed to do it right now, but recently they announced that it will be delayed for next 18 months. So it's a deal. The nice thing about this protocol is that there's no need for processing power here. You do not need to have powerful computer or a powerful GPU card or any specialized hardware to do it. You can really now run the node in these networks using something like Raspberry Pi right now. Of course, with some bigger storage, because still the whole history of the blockchain has to be stored somewhere locally on your computer. Algorithm determining the algorithm with which elects the node which gets to add the new block to the chain uses different factors here. In fact, in this proof of stake protocols, they no longer use the term mine. They use the term mint to somehow distinguish those two worlds. Algorithm, of course, because it's decentralized, cannot contain on any external party, so there should be some other way to elect the new block maker. And to elect this, the most important factor is the stake. That's why it's proof of stake. So this works like this. There's a number of nodes, like in the previous version, but they are not calculating anything blindly. They in this case, the owners of the currency are able to somehow delegate their money to the nodes. So they are not making any they are not moving their money to this node. They are just delegating this. So this is kind of owners of the currency are voting with their money to the nodes. And the more money is delegated to the node, the bigger chance it gets for the next to be elected as a next block creator. So here we see that there's some, well, rich people delegated the millions of ADA. ADA is a currency in the Cardano blockchain, by the way. So here's the big stake. Here's a very small stake. Here's a medium stake. And of course, using this algorithm, this node 1 will get elected over and over again because it has the biggest stakes. That's why this algorithm isn't so simple. This is not just a number, just the amount of money that decides about it. There's multiple factors. This mathematics is here to scare you, of course. So the proof of stake algorithm gets a lot of factors. Despite the stake, there is something called pledge. I will tell you about this later. There is a bit of randomness. There is really there are different ways to countermeasure this monopolization of the blockchain by the people having a lot of money and delegating it to the nodes. And one of them is that the node gets saturated. So once the node contains, I suppose now more than 1% of the cryptocurrency value here, it becomes saturated. So it is not elected to be well, the block producer anymore. And why is it important for people delegating the money here? Because one of the nice interesting features this proof of stake has is that people who are delegating money to the node are also paid if the node is elected. So the more money you put on the node, the more percentages of the money you will get back once the node is elected. This is an example of the node. It happens to be my node because I installed one myself at home. And you can see that this node has an active stake of 1,000 ADA right now. That if creating the node, you also have to declare the number of the ADA that is your operational cost. So this is what you are this is what the owner of the node is getting paid if the node is elected, and this is supposed to cover his costs somehow. You also describe the percentages of the money you would like to get from the whole money, and you also have to do a pledge. Pledge. This is the amount of money that you have to put on the on your note, and you are not able to get them back unless you close the note. So this is kind of blocked money from the owner of the note. The ideas behind these algorithms are quite smart, because if you want to earn money on running the node, you have to first put a lot of money in the hardware. You have to be sure that the node is always up, so you have 100% SLA. You also would like to have a big pledge, because the pledge is one of the factors. And if you want to lure people to delegate the money to your pool, you have to somehow balance all of this. Once the block is selected, once the node is selected and the block gets constructed, the node operator gets this operational costs and gets the declared percentage of the whole amount of money. And then the rest of the money is distributed to the stakeholders, to the people who delegated the money to your node, proportionally to their stake. So if they are just winning some money, and it gets transferred to their accounts. Which is important, the staking, delegating your money, does not block the money from the perspective of stakeholders. You can get your money from one node in any time and put it somewhere. It also does not include any physical transfer of any money. The monies are not on the node, so nobody is able to steal your money. This is just information that the money that you have, you're voting with your money to this stake pool. So these are two main algorithms currently used. The one relies on the brute force. The second one relies a little bit on psychology of people. The second one becomes more and more popular, and for a technology to survive, the bigger players are trying to migrate to these new versions of the consensus algorithm. Okay, you probably also heard about smart contracts in the context of the blockchain. Quite recently, they broke out a story with something called NFT, and NFT is really the implementation of one of the smart contracts on the Ethereum blockchain. So what is a smart contract? This is the extension of this idea of decentralized currency, decentralized money, into decentralized contracts. By contract, I mean that, when you are buying something, or buying the insurance policy, or taking part in some auction, you are assigning kind of legal contract, and this sign on the paper and the trust that you put into the party that you signed your contract with is a guarantee for this contract to be fulfilled. But of course, it all relies on third parties or on external trust. And as we do not trust anybody right now, it would be nice to have the mechanism that will ensure that our contract will get fulfilled, but without any third party to guarantee it. And this is also implemented on blockchain right now. The pioneer in this technology was Ethereum blockchain. They introduced it with great success, and there's a lot of work in this area right now to implement different financial services directly on a decentralized platform. Also, other platforms started to develop this. The Cardano, for example, is working very hard to make it available to the public. So, what are these smart contracts? The smart contracts are really the small pieces of software that the developers write in specialized languages, and the software is executed on specialized virtual machines inside of the blockchain nodes. Right now, the most popular one is called Solidity. This is the variant of something quite similar to JavaScript. And the incoming smart contract in Cardano will be based on the subset of Haskell language, the functional language. The idea behind the smart contract is that very similarly to the transactions, you are putting your code on the blockchain. And putting your code on the blockchain creates very interesting effects, because first of all, because it is encoded in blockchain, it becomes immutable. You cannot change this code. Once the code is deployed, it cannot be changed, it cannot be updated, because the address of this code is this code SHA 256 hash. So sorry, there's no updates on of your smart contracts. You can only create the new smart contract and redirect your customers to it. This is also a democratic process, because due to the nature of the blockchain, everybody can add smart contracts. There's no license for it. You can just put anything you want on contracts in the contracts code and publish it on the blockchain. But of course, there's one limitation. Every move and every transaction on the blockchain costs. It costs some operational costs. Every transaction has a cost, which is automatically deduced from your account. So every transaction is also connected with some creator account, and has to be signed. And of course, it's written. The transaction itself is written on the blockchain, and shrinks your amount of money that you have there. So what is the anatomy of this of the smart contract? The smart contract is run on a virtual machine. Of course, because this is a blockchain technology, it is run on some computer in the network, and then it is run on some computer in a network during this creating of the block, and then the execution of this code is confirmed by more than half of the network. So these all limitations which were put into transactions also kind of have effect here to assure that nobody will be tampering with these smart contracts and try to influence their outcomes. Each smart contract has an address, has an account connected with this, and this address is calculated from the smart contract's hash of the code. So you can send some money or some message, send some number into this address, and this becomes the entry point of each smart contract. So once you make a transaction to this address, the smart contract with the data that you send here gets executed, and as a result, it can create other transactions, or it can call other smart contracts. So they can be chained. But the main rule is that the smart contracts do not get executed by themselves. There's no automatic smart contracts. You have always some user has to send something into this smart contract address for it to be executed. And smart contract can also preserve some state. So it can have some internal data connected with it. And this data can be either in memory of the machine that the smart contract is executed, or the data can be persisted on the blockchain. So if you want to, the blockchain becomes kind of hard disk for the smart contract. But of course, as I mentioned before, everything costs here. So the storing the data in memory costs. The storing the data in blockchain costs even more, because to encode something in a blockchain, you have to pay somebody to mint or mine a new block. So this contract is executed well generally everywhere. The one computer that gets selected to make a block is then paid for execution of this contract. So this is also why this initial transaction has to be from some account, from some address, because to execute the smart contract you have to pay in front for execution of the smart contract. And this becomes tricky because, for example, in Ethereum you have to pay something that is called gas. So you are kind of delivering gas for this machine to work and to execute your smart contract. And it can happen that that this contract, I don't know, gets confused, or there's a bug in it and it doesn't end. This is the so-called halting problem. So you do not know the nature of the code, so you don't know what's happening inside, and inside there can be some infinite loop. But to prevent this infinite fragments of software to make problems on the nodes, because as I mentioned, this has to be executed on every node in the network. This gas gets depleted on every line of execution of the program, and this gas also gets depleted every time the smart contract is using memory or the blockchain to persist the money. And if this gas runs out before the contract is executed, this execution stops, and the contract is in a failed state. And what's more important, you are not getting refund for this gas. So gas has been spent, sorry, no refunds. What's also interesting, because of this limitation of the number of transactions on the blockchain I mentioned before, you can prioritize your execution of your smart contracts by setting the higher gas price. So this one on one side will prioritize your execution among the miners or minters, because they will get more money for executing this. But this will, of course, limit the number of your customers, which will be which would like to call your contract, because, well, it will cost them more. Okay, so if everything costs, how we are supposed to, we as the developers in the smart contracts world, to how are we testing our software? In both languages, and so in case of the both platforms of Ethereum and Cardano, it's nice to nice to say that the Ethereum language is called Solidity, and Cardano runs on Haskell, of course. There is something which is called mainnet, and this is the real network, the real blockchain. And there's also the testing blockchain called testnet. So you on a testnet, you are not dealing with the real money. You can test everything you want, but once you deploy it to the real blockchain, the money gets real, and of course the money gets spent. And this is, well, that's a lot for one time, I understand, but to finish this one, I would also like to tell you about the something which is a problem for blockchains right now, which is called blockchain trilemma. There are three factors important in this technology. So first of all, it is decentralization, the security, and the number of transactions per second the blockchain can support. And the problem is that only two of them can be achieved at once. So once you are trying to maximize the transaction per second, either security or decentralization will decrease. If you want to increase security, you have to sacrifice other transactions per second or decentralization. If you want to improve in decentralization, you of course can have the problem either with the number of transactions per second or security. This is connected to the fact that the idea behind the blockchain itself is to have everything distributed throughout the world. So once the decentralization increases, so once your network of nodes servicing your network becomes bigger and bigger, it becomes harder and harder to perform so many transactions per second, because you have to agree, half of the network at least have to agree with the results. And the nodes have a different processing power and so on, so you have to really have to wait for nodes that are slower. You of course can make some adjustments that will not be so thorough in checking your transactions. You can say, okay, 30% of my nodes are okay, but in this case, of course, you are hampering security. So this is how it goes. How it goes. Now, right now, this is the problem the creators of the blockchains are fighting with, how to create the network that will be decentralized, because in this way the people taking part in it will have some have bigger trust in it. It's more and more difficult. Once the more decentralized network gets, it's more the harder it gets to manipulate the network. Of course, they want the network to be as secure as possible, because this also has to be cryptographically secure, and this is one of the main features why the blockchains are touted as a next step in the financial world. But of course, if the blockchain is to have success in this world, it has to be able to support the thousands of transactions per second at least, to keep up with all its success. This for now is unsolved, but there are some nice ideas behind of it. Each of the platform has a different approach. This world is, just to sum it up, this world is surprisingly deep and surprisingly vibrant. There's really a lot of projects taking place, a lot of blockchains developed concurrently, but also on a particular blockchain there's a lot of initiatives or technologies that are growing and growing. So this whole environment is tremendously rich. I just really scratched the surface of it during my quest to start this Cardano node. But it looks very promising, and it's look very, very interesting, because it is also the great change in the principle of how we are dealing with money and how the countries are dealing with money. The countries lose all the power over money they use in this case. That's why they are so reluctant to adopt the cryptocurrencies, like recently China, for example. But on a bright side, there are some countries, unfortunately not so big as China, which are embracing the blockchain currencies. For example, yesterday, I suppose San Salvador announced that they will be using blockchain as a national currency. Not so big as China, but still. Thank you very much for listening. If you have any questions, please ask, but I suppose everybody is quite tired right now. No questions, so thank you very much for attending. 30 persons made it to the end. I think for a first time it's quite a good score. Thank you and have a nice weekend.